Hello everybody, welcome to my channel, and today we will talk about atomic orbitals and electronic configurations. Well, before starting the lesson, I'd like to share the photos of the books which I used for preparing this material. Well, let's now start. Let's start with atomic orbitals. If we imagine an atom, let's take an atom of hydrogen, and we visualize the planetary model of the atom of hydrogen suggested by Niels Bohr. We see that it consists of a nucleus and an electron that is moving around the nucleus. So this is how we imagine atoms. Well, if we take not the hydrogen atom but other atoms, we can say that there will be more orbitals, like more than one orbital, and in this case, there will be more electrons on orbitals. Let's now imagine the atom like a big house, a big building. And this building consists of several flats. So these flats will be considered as energetic levels of atoms. Like every orbital is on one energetic level. Let's go step by step. Let's first take this example with a flat and understand what is happening. Imagine that this is a big building. So this building consists of three flats. On every flat, not flats but floors, three floors. And on every floor we have flats. And every flat consists of rooms. Let's now see. On the first floor we can have only one flat. And one flat has only one room. If we go to the second floor, we can see there are two flats. One flat will have one single room, the other flat will have three rooms. If we go to the third floor, we can see three flats, so one flat with one single room, the other flat will have three rooms, and the third flat will have five rooms, etc. Every time when we go higher by levels, we will get more flats and more rooms. And imagine that in one room there can be only two people. And you can see these are people who would like to go and live in these rooms. And if we consider that in one flat, in one room, there can be only two people, this is how they can arrange inside of this flat. Let's talk about atomic orbitals now. And let's make the link between orbitals and between the rooms. There are four main types of orbitals that will be considered. So S, P, D, and F. S orbital has a round form. It's like a circle. And S orbital is situated on S subshell. Well, P orbital is on P subshell. It had the form like number 8. And then D subshell or D orbital, which is situated on D subshell, had the shape of a flower. And if we are talking about F orbital that is situated on F subshell, we will see that it had the structure of a complicated flower. Okay. And if we make the link, like S subshell consists of one orbital only. It's like the flat which has only one room. P subshell consists of three orbitals. So on one P subshell we have three orbitals, like a flat with three rooms. On D subshell we have 5 rooms. And we have 7 rooms on F subshell. By the way, and these letters S, P, D, F correspond to the words, the first letters of the words sharp, primary, diffuse, and fundamental. This is from where these letters come from. Okay, we will not focus on this. Let's continue now. Again, let's see now our flat. Or let's say our building with a number of flats. So every floor will correspond to an energetic level. Imagine now that this is not a house, it's not a building, but it is an atom. So it consists of energetic levels, And on each energetic level, or we can say on each shell, there are subshells. So every floor is one energetic level, or let's say shell. It is also called shell. On every shell, we have subshells, like flats. On every floor, we have a flat. So on every shell, we have subshells. And on every subshell, we have orbitals. Orbitals are shown like squares that look like rooms in every flat. And in every orbital, we have electrons. Electrons are like humans which enter the rooms. Just remember this analogy, it will make it easy to understand. So, on every shell, we have subshells. On every subshell, we have orbitals. And on every orbital, we have electrons. The maximum number of electrons on an orbital is 2. Well, we will talk more detailed about them, about shells, subshells, orbitals, in our further video about quantum numbers. Here, let's focus on electronic configurations. And now let's see. So on the first floor, let's say on the first energetic level or on the first shell, we can have only S subshell that will consist of only one S orbital. On the second shell, we have two subshells, S and P. S subshell consists of one S orbital. P subshell consists of 3 orbitals. On the third shell, we have 3 subshells, S, P, and D. Well, S always consists of 1 orbital, P consists of 3 orbitals, and D consists of 5 orbitals. And on the first shell, we will have 4 subshells, S, P, D, and F, etc. We will not go further, actually. We will focus only on the first 3 levels. Okay, so let's go. Let's see. So these rooms, this window that are shown with the yellow arrows, they are S orbitals. These ones, like as you see, we have 3 windows. It's like a room with a flat with 3 rooms. So this will be P subshell and 3 orbitals, and the subshell that had 5 orbitals is called D subshell. Well, let's now understand what is an electronic configuration of an atom and how we can write them. So let's write an electronic configuration for sodium and understand it. So you can see the sodium atom with the arrow in the periodic table. If you pay attention, sodium is situated in the 3rd period. 3rd period means that it will have 3 energetic levels, like 3 shells, or a building with 3 floors. Let's continue. So this is our sodium. As you see, its atomic number is 11. So if it's 11, it means it will have 11 electrons as well, because if the number of protons is 11, number of electrons will be the same. Again, let's have a look at this. We have S on the first level. On the second level, we have S and P. On the third level, we have S, P, and D. On the fourth level, we'll have S, P, D, and F. Okay, let's focus on the first 3 ones, because sodium has 3 levels. This is how we write the electronic configuration for sodium. So we first write 1, it means the first energetic level. Okay, 1s on the first level, we have only S subshell. And S subshell consists of 1 orbital, and the maximum number of electrons that can be on this subshell, on S subshell or S orbital, will be 2. So we're at 1s2. So it means that 1 is the first energetic level, or shell number 1. S means that it is S subshell and consists of one orbital only, and small 2, the uppercase, means that there are 2 electrons. So from 11 electrons, 2 electrons will be situated on one s subshell. So, okay, what about the other 9 ones? So we cannot add all the electrons on s on one orbital. So we go to the second floor, because we know that on the first level we have only s subshell. If we go to the second level or second floor, if we consider the building, there will be, we said, s and p subshells. So we have 2s and 2p. First, we start filling 2s orbitals. So 2 electrons will come on 2s. It will be 2s2. On p orbital, on p subshell, we have 3 orbitals. On one orbital, we can have 2 electrons. So if there are 3 orbitals, we can have 6 electrons. So 2p6. It makes up 10. Already 10 electrons are situated, but there are 11. The one is missing. That one will go to the third floor and fill 3s1. Here, as you see, it's not 3s2, but 3s1. So the maximum number of electrons on the orbital is 2, but it can be less. So now, as you can see, we have overall 11 electrons. All of them are situated on their places. Let's now try to draw it, again making the analogy with the building. So one s subshell has only one orbital. The orbitals are drawn like squares. So 1s is 1 square, and 2s is also 1 square. 2p consists of 3 squares, p because that's 3 orbitals, yes, and 3s, again 1 square. And let's start filling. So first of all, electrons start from the first floor. Imagine that you would like to buy a house and you are trying to buy a house on the first floor. It has a lower energy, so filling starts in this order. So 1s, 1 electron comes on the s orbital. We draw it as an arrow. Now the second electron comes to the same orbital, but as you pay attention, the direction will be different. So this electron will move in the other direction. This is called the spin of an electron. They will be different, because if they are equal, well, not only equal, but if they have the same direction, they are same. In this case, just this case is not possible because they have the same charge. They both are negative, and for this reason, they cannot move together in the same direction. They will always repel each other and move in opposite directions. So we draw them with opposite spins. Okay, 1s is full. 2 electrons are there. Let's now move to the 2s. And we see that 1 electron fills it. The second one with the opposite spin also fills this orbital. And then we start filling the 2p orbital. It is a bit more interesting. Look, 1 electron fills in 1 orbital of the p subshell. So this is subshell, p subshell, and it has 3 orbitals. Electron fills 1. Then the second electron comes, it will fill the second orbital, not the same orbital with this one. If there are empty orbitals, electrons first will fill the empty orbitals. Imagine that you'd like to stay in a flat together with your group mates, and there are 3 rooms. Of course, you'd like to stay in a private room. You would not like to stay together with someone in one room. It's easier to have your private room. It's such an analogy. So electrons have they want to fill in the separate orbitals. So of course the third electron will come to the third orbital. Okay, all 3 orbitals are now occupied with electrons. But we have 6 electrons here. So the 4th electron will come to the first orbital, then 5th electron, and 6th electron. This is the order how we fill them. Okay, 10 electrons are already situated here, and now 1 electron is missing. So it will go to 3s subshell. and 3s orbital. So it fills in this orbital. This electron will be unpaired. This is non-paired electron. So this is how we write and draw the electronic configuration of sodium. And now let's imagine again, let's take the picture with a flat and imagine how it will happen. So these are people who are settling. So this is 1s1, you see? Then we have 1s2, 2s1, 2s2, you see? And they will fill in one by one the orbitals, and after that the second electrons will come to every orbital, and 3s1. So 3p, we said that on the third level we have 3s, 3p, and 3d subshells. So 3s1, it means that 3p and 3d remain empty. Okay, now to make a better practice, let's now try to draw electronic configurations for potassium and for aluminium. Now I will show it drawing by myself. Let's now start with potassium. If we have a look at the periodic table, we see potassium is situated on the fourth period. It means it has 4 energetic levels. Its atomic number is 19. It means it has 19 protons. So it will have 19 electrons. Okay, let's now do it. So we are starting now to draw the electronic configuration for potassium. Right, potassium 19. So its atomic number is 19. It means our potassium has 19 protons. Hence, the number of electrons will be also 19. So we have to situate this 19 electrons here on the subshells. So potassium, we said, is in the fourth period. So there will be 4 energetic levels. Let's now start. Let's start writing it. 1 S. We start from the 1. Yes, on 1 we always have S. 1 S2. On S we can have always maximum 2. We close the door. So that's all. On the first floor, on the first energetic level, we have no more subshells. Only 1 subshell and 1 orbital. We go to the second floor now. 2 S2 and 2P6. We close the door. Already 10 electrons. We have 19. So 9 electrons are missing. Let's come here. 3s2. Okay, it's 12. Then on the third level we have 3p as well. We write 3p. And on p we have 3 rooms, maximum 6 electrons. 3p, 6. Now it's 18. 1 is missing. So according to logics, we would say it should be 3d1. 3d, because on the third energetic level, we have also d subshell. And this d subshell has 5 orbitals. But the energy of d subshell is higher, so electrons start filling the orbitals with lower energies. That's why we start in this direction. 1, 2, 3. So 3d subshell have a higher energy than 4s orbital. So that's why what happens. 4s, 1 electron, first of all comes to this 4s and 3d remains 0. Then 4s1, it will be 4s2. When 4s is completely filled, after that we will fill 3d subshell. Okay? 3d cannot be filled until 4s is not completely filled. It's like, imagine that you are buying a flat or you are renting a flat, and it's easier for you if you are alone. It's easier to rent 1 room rather than 5 rooms because it's more expensive. It's just for analogy. So on 3D subshell, electrons will be filled only when 4s fills completely, like this. So actually 4s has a lower energy than 3D. The filling order will be different. Let's write like this. This is the filling order: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d0. This will be the filling order. This will be the energetic order. Well, look, 4s has a lower energy than 3d. But as soon as one electron comes to 3d, 3d becomes filled, it becomes lower in energy. Until they are empty, 4s has a higher energy. But as soon as one electron comes on the d, its energy will decrease. So that's why energetic order is like this. Filling order is like this. So you can write both of them, and both of them are correct. Great. I will just cross this part in order not to get confused. And we will be focused on this one, okay? So let's now draw their orbitals. 1s. This is 1s. It has 2 electrons with opposite spins. Then we go to 2s. 2s2, we have 2 electrons, and 2p. P subshell has 3 orbitals. On this subshell we have 3 orbitals. So this is how we will fill them. 1, not like this, but here. 2, 3, then 4, 5, and 6. 4, 5, 6. Then 3s2, 3s2, 3p6. Again, remember the order. It will be like 1, 2, 3, 4, 5, 6. 3D will be 0. We can draw it or not to draw. I will draw to show you, but we may skip even this part because it's empty. I just draw to show that there are 5 orbitals on this subshell and they all are empty, and 4s1. In 4s1 we will have only 1 electron, like this. So this is how it works. And now let's talk about exceptions. So here you can see these 5 elements are exceptions, like copper, chromium, argentum, aurum, and molybdenum. But usually we are focused on copper and chromium. This is the simplified version. Usually we don't try 2 big electronic configurations. Anyway, if you are required, if maybe in the university or at school where you study, you are having this course and you are required to draw big electronic configurations, in this case, you have to remember that for these 5 elements, for them all, there is an exception. Now I will tell about this exception, why it happens, what I mean by exception. But let's now focus on copper and chromium. I will show you the case with copper, and the same thing will be for all of the others. So, in this case, 1 electron from 4s falls down on 3d. It means like 4s is not completely filled, but already 3d starts being filled. Now I will show you this example. Okay, let's take copper. We said that copper has atomic number 29. Atomic number 29 means that it has 29 protons, so it will have also 29 electrons. And we have to now situate them. Let's start. Okay, 1s2, 2s2, 2p6, again, close the door, because on the second energetic level we have only S and P subshells. On the third energetic level we have 3s2, yes, 3p6. We also have 3d, but we keep it, we don't write it. We close the door, we first go to 4s. Let's count how many electrons are missing. 2 to 4. Here we have 10, 18, yes, 18. We need 29, so 11 are missing. Let's write 4s2, and now 10, again 10, 20, 9 are missing, so 4s is completely filled. The 9 electrons will come on D, 3d9. This is the correct electronic configuration for most of the elements. However, for copper, we said copper is an exception. This is what will happen. One of the electrons on 4s, from 2 electrons, will fall on this 3d, and indeed we will get such a configuration, 3d10, 4s1. This happens for copper, chromium, silver, gold, and molybdenum. For these 5 elements. For all the other, this does not happen. For all the other, this order is correct. First for S is filled, and then the previous D level is filled. But for these 5 elements, you should remember this rule. So, okay, let me erase it and move it like that. So, it's not like this, but it is like this. And let's draw now electronic configurations again. Let's draw the orbitals. 1s2. This is for 2s2. This will be 2p6. 1, 2, 3, you see? And then the opposite direction. 4, 5, 6. This once. Then 3s2. And 3p6. Let's draw it. 1, 2, 3, 4, 5, 6. Then we draw 3d10. 1, 2, 3, 4, 5. It has 5 orbitals. 1, look again separately. 2, not here. You see, not here but here. 3 is not here but here. 2, 3, 4, 5, but we have 10. So 6, 7, 8, 9, 10, and 4s1. It is 4s1. So this is the correct configuration. We see one electron is unpaired, one lone electron. And finally, for writing and drawing electronic configurations of atoms, you have to remember 2 rules. Hund's rule and Pauli exclusion principle. Let's consider each of them. So, Hund's rule states that, well, the electrons will have the lowest energy arrangement in a subshell if they are filled, first of all, separately in separate orbitals rather than 2 electrons in one orbital. As I said, even here in the picture you can see, when we are talking about 2p subshell with 3 orbitals, first of all, electrons will fill separate orbitals, and after that they will be paired. So this is according to Hund's rule. So the lowest energy arrangement of electrons in a subshell is obtained by putting electrons into separate orbitals in the subshell with the same spin before pairing electrons. So first of all, they will fill the orbitals separately, and only after that, when all the orbitals are filled, they will start pairing. And if we turn to the Pauli exclusion principle, we can say that electrons fill in the orbitals starting from the lower energy to the higher one, And in one orbital, there can be no more than 2 electrons with different spins. So the maximum number of electrons on the orbital is 2, and they both should have different spins. That's all. So I recommend you to do some practice, write electronic configurations of some atoms. Also try to write the electronic configuration for the exception atoms as well. Try, do your best, and if you have questions, you may contact me. That's all for today, and I hope it was clear enough. If you have any further questions, you may contact me, you may write me, and I will try to answer all your questions.